welcome to part 3 of matrices. All right, so let's get a go on this one. So, can you guys recap what we did in the previous videos? Well, in the first one, we learned how to order a matrix. And in the second video, we learned some basic properties of addition of matrices. I said I would have gotten into the subtraction, but we did not get a chance. So I am just going to touch on that on this video, as well as finally get into matrix multiplication. So touching on the last video where we didn't exactly get a chance to do any subtraction, let's just look at the subtraction of matrices. Now, just like for addition, if you were to subtract matrices, you must make sure that they have the same order as well. Okay, so you cannot work with matrices that do not have the same order for addition and subtraction. All right, so just a quick example. If you had the matrix 2, 3, -1, and 0, and you wanted to subtract 1, 2, 1, 0. First of all, you got to check the order. Remember, the order of a matrix is given rows by columns. So the first matrix, you can tell that has 2 rows, 2 columns. So this is a 2 by 2. Second one, it's also a 2 by 2 matrix. Because they both have the same order, we can definitely perform subtraction. It's legal. And how would we do that? We would look at the coinciding location of numbers in each matrix. So in the first matrix, we have 2, and that coincides with 1, and we are doing subtraction. So 2 subtract 1 gives us 1. Similarly, we have 3 in the first matrix coinciding with 2 in the second matrix, meaning that they are in the same locations. And 3 subtract 2 gives us 1. Moving on, in the first matrix, in the lower corner, we have -1. And in the second matrix in the lower corner, we have 1. Those matrices, those numbers, sorry, coincide in terms of their position. And if we were to perform subtraction, we would get -1, subtract 1, which gives us -2. And lastly, we have 0 coinciding with 0. And if we subtract those, we'll get 0. And notice that our answer always works out to be of the same format as the matrices we were subtracting. So in addition and subtraction of matrices, not only is the order of the matrices important in order to know if you can perform addition or subtraction, it also tells you the order that your answer will take. So they all look the same. Now, take note that with addition of matrices, the addition is commutative, meaning that if this first matrix here, if I called it A, let me take that off from this side. I'll write it on the bottom. If we were to call this matrix A here, and this one subtract B, take note that that is not the same as B subtract A. So for subtraction, subtraction of matrices is definitely not commutative. It also would not be associative. So please take note of that for subtraction of matrices. Okay, guys. So today's lesson is really supposed to be on matrix multiplication. Now, I think I'll clear my page. I'll probably need a lot of space for this one. Don't get scared. People are already getting sweaty palms and stuff. You'll just relax, just relax, just relax. It's actually going to be very nice. It's going to be nice and relaxing. I'm going to just take my time, you know, and you guys are going to enjoy this matrix multiplication process. Just keep your minds open, okay? Multiplication. Yes, sounding out words and spelling makes it oh so much easier. Okay, guys. So notice that we had rules. We had certain things to look for when we were doing addition and subtraction. The order had to be the same. Well, it's just a tad bit different when it comes to matrix multiplication. And in order to explain this, I'll show you by example. Let's just see. For example, on screen, we had a question that looked like this. Let's just say we had 3, 5, and we wanted to multiply that by this matrix, 1, 2. Let's just say we wanted to multiply those two. Now, straight away, you can tell they look different, and they definitely are. Let's name them and find out what's going on here. So what's the order of this one? Well, we have one row. So this is a 1 by how many columns? 2. This is a 1 by 2 matrix here. What about the second one? How many rows does this have? I'll just put on the corner here. It's row by column when you're finding out the order of a matrix for those of you who can't remember. Okay. So the second matrix here, we have 2 rows this time, and we have 1 column. Now, if you observe, what you'll notice is that they are definitely not the same order. Like literally, we can never add or subtract these 2 matrices. They are just not the same. They are not compatible. But multiplication, the compatibility status, it's just a little bit different. So what you actually check to see if you can multiply 2 matrices are these 2 inner values here. If these numbers are the same, then matrix multiplication can take place. So exactly what are those 2 inner values? What do they represent? Well, if you want to note, if, let me see, if the number of, what is that, row by column, if the number of columns of the first matrix is equal or the same to the number of rows of the second matrix, then you can multiply these matrices, right? That's the rule for multiplication of matrices. If the number of columns of the first matrix is equal to the number of rows of the second matrix, I'll put M for short to represent matrix, then we can multiply, or in a simpler way, you guys can just simply write down the orders next to each other like I did, 1 by 2, 2 by 1, and just look to see if those inner numbers are the same. You can call them the inner. Okay, and a second thing that I do with these is that I also connect the outer. So what I do is I draw a little thing and I connect the outer. And what is the importance of connecting the outer? Well, the outer, in this case, the outer is what? It's actually 1 by 1. This gives us the order of our final answer. In other words, it tells us how our answer will look. Because remember, if you really look at this question, you have a 1 by 2 matrix, then you have a 2 by 1 matrix. How do I even know what my answer is going to look like? Is it going to look like the first one? Is it going to look like the second one? Kind of a bit of biology here, you know, genes play a role. You have like chromosomes and stuff mixing in, and you don't know what the out product is going to look like. Well, there's a way. The outermost numbers of both matrices reveal what that baby matrix is going to look like. And in this case, it's going to look like a 1 by 1 matrix. How does a 1 by 1 matrix look though? A 1 by 1. What does that mean? Well, a 1 by 1 matrix just means one row and one column. How does something look when it has one row and one column? Well, if I were to draw a diagram, something has one row, I'll represent it by a dot, one row, that's just row 1. And if something has one column, it also just has one number. So that's column 1. So pretty much in a nutshell, a 1 by 1 matrix is just simply one value contained in brackets, where you have one row, that value stands at its first row and its first column. All right, guys. So my answer, finally going backwards here, my answer for this question would actually just look like one value here. All right, guys. So we are going to get into finally, how do you actually multiply the numbers? Now that we know we can multiply because the inner numbers are the same, how do we actually multiply? Let me take it down below. All right. So we had a 3 by 5 and a 1 by 2. I'll hold it right here. All right. So going back to the example, we had a 3 by 5 and we had a 1 by 2. All right. See? All right, nice. So how do we actually go about multiplying? Well, guys, when you're finding the product of a matrix, you have to be very careful. You must always multiply all the rows from the first matrix with the columns of the second matrix. That's how matrix multiplication is performed. Let me go ahead and show you guys what I mean. So for example, to get this answer, if I were to multiply, I would perform it in the following way. I would multiply this 3 here with this 1. All right, so let me open my brackets and I'm going to write down 3 multiplied by 1 plus, I am also now going to multiply by 5 and my 2. 5 multiplied by 2. And I'm going to close my brackets. Now, you see, every single value, to get one value in a matrix, it usually involves multiplying an entire row by an entire column. You must multiply an entire row from the first matrix by an entire column of the second matrix. That is how matrix multiplication is performed. Row of the first by column of the first, row of the second by column of the second matrix, and so on. So in this question here, if we were to extend our answer through a process of simplification, you would eventually get 3 by 1 gives us 3 plus 5 by 2 gives us 10. And that just works out to be 13, right? So our answer, remember our answer was supposed to be a 1 by 1 matrix where we just get one value in brackets. Well, we have gotten one value in brackets. That answer is 13. So after multiplying this matrix, we have gotten the value of 13. Let's look at another example, because trust me, it takes a while to get the hang of matrix multiplication. It's very intense and it has a lot of rules. So you have to allow yourself some time to breathe and really soak it in. Let's look at a different example. Okay, so I'm going to put example 2 over here. And I am going to choose to multiply another interesting one like this, actually. What if we had something like vertically instead. What if we had 1, 3, 2? So that's by, let me see, multiplying this by 4, 5, and 0. All right, can this be multiplied? First of all, we have to perform our check. Let's order our matrices row by column. This has 3 rows and this has 1 column. Similarly, the second matrix, this has 1 row and it has 3 columns. All right, let's check those inner numbers. Are they the same? Yes, they are. So first point to note, we can multiply these matrices. Exactly what is our answer going to look like? Well, according to the outer numbers, our answer is going to be a 3 by 3 matrix. What does a 3 by 3 matrix look like anyway? Well, it means 3 rows and 3 columns. So therefore, 3 rows and 3 columns would look like this. We have 3 rows and we have 3 columns. So we know our answer is going to gear up to be very large. So we're going to set up a little situation where we have huge brackets. And we're finally going to begin our multiplication. Now remember, multiplication takes place in a format where we choose rows from the first matrix and we multiply them by columns in the second matrix. You never choose columns from the first, only rows. So to get this answer, guys, let's breathe and take our time. All right, so to get our answer, we would first look at the first row. Now, our first row is 1. We only have 1. So what we are going to do is we are going to multiply that 1 by the first number in our second matrix that belongs to our columns, right? So the first column has 4, so we're going to multiply by 4. All right, and then that's the end. We have nothing left in that row. We have nothing left in that column. In the first matrix, the only number in the first row was 1, and in the second matrix, the only number in the first column was 4. So we have nothing left to work with. So we stop there. I think I will highlight it from now on so you guys can see it clearly. Let me choose some numbers, some colors here. I'll choose red. All right, moving on to the second one. To get the second value here, we would look once again at the first row. All right, so I'll highlight this first row. And we are going to look at the second column this time, right? So you have to make sure you multiply every single row by every single column, right? And you keep moving along. So in our first matrix, we have 1 as the only number in our first row, and we have 5 as our only number in our second column. So our second value here would be 1 by 5. Moving ahead, I will erase this. All right, get back my black in there, and okay, boom. And then still keeping up with that first, the answer still has 1 more value to get. And of course, I'm using my answer 3 by 3 to know exactly how my answer is going to be laid out. Okay, so keep that in mind. So now we're going back to our question. We're still using this first row value of 1 because we're still generating values for the first row in our answer. We're going to look at this one last time, and we're now going to multiply it by our 0, which is the last and final column of our second matrix. And there we go. And we have generated very successfully our first row for our answer. Now we have 6 more values to go. We're going to now look at that 3, guys. And we're going to take that 3 and we're going to multiply it by 4. We're going to take that 3 and multiply it by 5. We're going to take that 3 and multiply it by 0. Notice what I did. I simply I'm multiplying my second row of my first matrix by each of the columns of my second matrix. All right, you always multiply your rows of your first by your columns of your second. When you're finished with that 3, go ahead, stop using it, and you move on to your last number, which is our 2. So we're going to multiply your 2 by your 4. You want to multiply 2 by your 5, and you want to multiply 2 by your 0. So once again, what we did is we took the last row of our first matrix, and we're simply multiplying it by each of the columns of the second matrix. Cleaning this answer up, we are going to get a nice simplified answer of 4, 5, 0. You'll get zeros here, you'll get a 12 here, 8 here, 15, and a 10. And that's your final answer. How do I know it's correct? Well, first of all, if I remember, when I was using my method of identifying what my answer will look like, it's supposed to look like a 3 by 3 matrix. Is this a 3 by 3 matrix? Yes, it is. It has 3 rows and it has 3 columns. So guys, I think students have a lot of issues with these 2 types of matrix multiplications, but the more popular one that comes tends to be the 2 by 2 matrix, which is why I kept it for last. It's actually, I don't want to use the word straightforward, but it's actually easier because the number of rows and columns tend to be very balanced. Okay, so one example that you guys would just love looking at is this third example. This is the sweet spot, if you want to call it that. And this is the ones that truly do come in your exam paper. If we had 1, 2, 4, 0, and we wanted to multiply by 2, 1, 2, 5. Notice that when you're multiplying matrices, you don't really see that multiplication sign between them because brackets means multiply, right? So using those, I mean, all the rules of maths always end up coming into play if you think about it. All right, guys. So once again, you name your matrix. First thing on the plate, first thing on the agenda. The order of both matrices are the same. Our inner numbers are the same, so these matrices can be multiplied. And what is my answer going to look like? It's going to look like a 2 by 2 matrix. What does that look like? A 2 by 2 matrix has 2 rows and 2 columns. So I kind of know what my answer is going to look like. All right. So I set out my brackets, some pretty big brackets, and I go. I must select. You can only select rows from your first matrix and columns from your second when multiplying. So my first row has 2 values, so I'm going to highlight that. And my first column has 2 values. So how I want to perform this multiplication is by kind of pairing up values that I can legally multiply together. I would multiply my first row value, which is 1. And I'm going to multiply that by, I'm going to look at my second matrix now, and I'm going to multiply it by that first column value, which is 2. I'm going to add, because the reason we are adding is because we have not used the entire row and the entire column from both matrices. In the previous examples, we only had 1 value in our row in the example above, which is why we did not have that addition. But in this example here, you have more than one value. So you need to add in order to use every single value of your row. Continuing, we are going to look at that second value 2, which we have in our row, and we are going to multiply by the second value in our column, which we have highlighted, and that's also 2. And now we have sufficiently used all of the values in the rows and columns which we are working with. So we have nothing left to add or multiply. That's the end there. Now we can move forward to getting the other values. Let me see if I can erase this without taking out too much. Yes, we can. All right, guys. So now we're going to move forward. And we're going to still highlight that first row. But this time, we're going to highlight it by the second column. All right, so we used the first row here, and we multiply it by the first column. Now we're going to use the first row, and we're going to multiply by the second column. All right, and over here, what are we going to get? Well, I'm going to open brackets, and I'm going to look at my first row. I have 1 in the first location, and also in the second matrix, I have 1 in the second location. So I'm going to multiply those two values, add. I have 2 in my second location, and in the second matrix, I have 5 in the second location. So it's a matter of finding out which values coincide with each other. You want to multiply your first values by each other and your second values by each other. All right. Moving on, we have completed that multiplication. We have successfully used all of the numbers from both rows and columns. So we can move on to the third value here. And now how do we get the third value? Well, we have finished using row 1. We have multiplied row 1 by both columns. So we are finished with it. Now we would move on to working with the second row. So now we are going to look at that second row and find out what we will get when we multiply by the first column all over again. So we are using the second row and multiplying by the first column, and then we are going to multiply the second row by the second column. So sometimes it could help by writing down these as pointers to note exactly what values do I need to multiply to get these corresponding answers. So I want you guys to take a breath. This is what I said. Matrix multiplication can be a bit tricky. It's not so much tricky as it is very cumbersome. It's you have to see past the clutter, and you have to really understand what you're doing. You're always multiplying row by column, row by column, row by column. All right? Just remember your rules and take it very slow. So in this one, to get our third value, if you notice our answer, this third value here in particular, if you wanted to know how to even generate this third value is in the location in our answer. It's in the second row, and it's also in the first column. That's how they got 2 by 1. That's where it came from. Just point a note in the future. If you can't figure out how they are getting the 1 by 1 and the 1 by 2 and so on, it actually comes from the location of those numbers, right? So we are going to choose our second row with our first column. And in that order, the 4 is coinciding with the 2. Those are our first two values on either side. And we're going to add that to 0 multiplied by 2. All right. And lastly, we are still going to multiply that second row, but this time by our second column. So we're going to have that 4, which is the first value. It's going to coincide with 1 of our second column. And then we're going to add that to our last two values, which is 0 by 5. All right. And it takes a lot of practice to get accustomed with these questions. A lot of practice. You just gotta take it slow, take your time. Everybody makes mistakes. I make mistakes a lot. Just simple calculator mistakes. You know, you might multiply something by 0 and not get 0. It happens. And I want you guys to know that sometimes when silly mistakes like those happen, it doesn't mean you don't know what you're doing. You can get an answer wrong, and it just means that you made a slip. You made a little error. Like, look over here, I wrote a multiplication sign. That's not supposed to be multiplication. It's supposed to be an addition sign, right? So little things like that, you'll see that mistakes do happen. It doesn't mean the end of the world. It just means you take the time to check over. You believe in yourself. Once you have put in the effort to understanding how to work a question, it's all about practicing, guys. The more practice you have, the better you'll get at something, because maths has a lot to do with memory. Your skills become better and better the more questions you're exposed to. Every teacher, every student that you see ace in all the exams, it's simply because they've had years of practice, and that is the key, right? But no amount of practice can save you from mistakes, right? So you guys, that's where checking over also comes into play. I don't want to make this video too long, but I would like to do one more example because I know a lot of students would be dying to see another example like this one. All right, so I'll show one more on the screen, and I'll try my best to choose one that has simple values. All right. What if you guys are given a matrix? Say they named it this time. They called it A. Let A be equal to 2, 1, minus 1, and 1. All right. And the question is asking us to find A squared. What do they mean? I have never learned how to do A squared, but you guys have done exponents. And you guys know that A squared, if I go to my little working column here, you guys know that A squared is simply equal to the product of A by A, if you remember your rules of exponents. And just applying that, you would see that that works out to be the product of the matrix A being multiplied by itself. So in a nutshell, essentially what they want you to find, guys, they just want you to multiply this matrix by itself. Okay, and let's see what our answer will turn out to be. Now, of course, from the previous example, these two matrices are both 2 by 2 matrices. Matrix multiplication is legal, and it results in a 2 by 2 matrix. So I will skip those steps out, but we will get straight into the multiplication process. So getting into the multiplication process, I'll write some really big brackets, and I'll begin. So I'm going to highlight once again remember you're choosing rows from the first one and columns from the second. I'm going to choose my first row here, these numbers, and I'm going to look at my first column. So those are the numbers that are involved in the multiplication process. Because I have multiple numbers involved, I would have addition. Had I had one number in my row and one number in my column, there would have been no multiplication. There would have just been, no addition. There would have only been a multiplication. But in this case, you have several numbers, so there will be some form of addition. All right, so that's one point to note if you didn't pick up on that from the previous example. And when you're multiplying, you want to make sure that you multiply by numbers that coincide with each other, kind of like similar locations-ish, if you understand what I mean. Like the first number in the first row by the first number in the first column. Then you multiply the second number in the first row by the second number in the first column. All right, and then we're good on the road like that. We're gonna go down the road like that. Ooh, I'm rubbing off my numbers. Now we're gonna work with this second column. So here it goes. And we're going to get 2 by 1 plus 1 by 1. All right, guys. Then we're going to move on. Doots, doots. Oh, I did out some of my number. Okay. I'm going to try my best to highlight this. I should have spaced it out better. That is why you need to prepare. Preparation is key, they say. It really is, guys. It really is. So we're going to multiply that first number, -1, by that first number 1 and add it to the product of 1 by 1. There we go. I think I should have changed my value so you guys would have seen clearly which numbers I'm using. Perhaps I might do a 2 example. Who knows? We'll see. All right. Finally, I am going to multiply my... Oh, I made a mistake. See why it's so important? It is so important to definitely highlight the right thing. I was supposed to multiply by my first column over here. I don't know if you guys saw that, but yes, I made a boo-boo. All right, guys. So we're supposed to multiply -1 by 2 and 1 by -1 here. And then, and it's because I highlighted the wrong values. That's why I was off key there. Now we're going to multiply second row by second column. And we're going to get -1 by 1 plus 1 by 1. There we go. Now that is correct. And this final answer will work out to be 2 by 2 is 4 plus -1 gives us 3. And 2 plus 1 gives us 3. Then we have -2 plus -1 gives us -3, I believe. And then finally, we have, what do we have here? -1 plus 1 gives us 0. So you guys can go ahead and you can check. I believe this is definitely correct. I have some answers worked out here. This is correct. And you guys can try that on your own. So I'm going to do a better example where I actually have different numbers because I feel like you guys aren't seeing where my values are coming from. I'm going to do a third and final example and just try to talk a little bit about identity matrices, and then we'll move forward in life, guys. We'll move forward in life. Okay, third example. Make it fun. Make it fun. We'll use some 1, 0, 2, and -1 here. And then over here, we have to change our values because I'm trying to show you guys, you know. Let's put 5. Okay, so we're going to take our time here. Okay, so we know these can be multiplied. They both are 2 by 2. The inner numbers are the same. They result in a 2 by 2 matrix. Let's just go ahead and perform the multiplication. So we're going to pick rows from here and columns from here. And my first row has the values 1 and 0. And my first column is 3 with 4. All right, so we have 1 and 0 and 3 and 4. So we're going to take those 1 by 3 plus 0 by 4. See how fast we're getting at it? It gets easier, doesn't it? Yes, it surely does. And then we're going to move forward to get the other one. All right, so we're going to keep with our first row. I'm going to try to underline our first row here. And we're going to go to our second column here. And let's see what values we'll get. We'll get 1 by -2 plus 0 times 5. And then down here, last time I made this mistake, down here, this value is in the first column part. So we have to use the first column to generate the answer for this that lies in the first column. I'll show you guys something in a bit. All right, so we have 1 by 3 plus 0. Oh, I did it again. Oops, I think I did it again. Oh, wow. I'm telling you guys. Yes, I did. It's so very important to make sure you highlight the correct thing. All right, guys. So you want to multiply 2 by 3 here. I had accidentally left the highlight on the first row. So I went ahead and I accidentally was multiplying the first row, which was the same thing. I was not supposed to do that. So yeah. Okay, so 2 multiplied by 3 plus -1 multiplied by 4. And then finally, let's make sure, guys, that we are choosing the correct column here. All right, so this is what I mean when I say it gets a little bit cumbersome. It's not difficult. You just have to take your time, okay? And we have 2 by -2 plus we have -1 by 5. There we go. Woo! That was a killer, guys. Woo! I felt like I took a workout there. So finally, our answers are 3. This gives us 3 up here and 0, so that's 3. This gives us -2 and 0, so that's the sum of that gives us that. This gives us 6 and -4, so when we add that, we get 2. And this gives us -4 and -5. So when we add that, we get -9. So guys, you have to take your time. You have to make sure you really remember to highlight the rows and columns that you have to multiply. And remember that it's the first value by the first and the second by the second, and you find the sum. Now, some students frequently have issues where they don't understand how to choose the rows and the columns, and how do you know to place that value. How do you know, do you place that value here or do you place it here? And they think that's the tricky part, but it isn't. Here's the advice I tell students, and it clears up everything. Remember, your answer has to be, for this type of matrix, it has to be a 2 by 2. Because you know it's going to be a 2 by 2. How do you know which rows and columns to multiply by? Well, I like to represent my answers by dots. And then what I do is I name my dots. I name my dots by writing down their location. For example, this first dot is located in row 1, and it's also located in column 1. The second dot is in the first row, but it's in the second column. This third dot is in the second row. It's in the first column. And my last dot is in the second row, and it's also in the second column. When you name your dots, you actually are able to decipher which rows and columns you need to multiply by in order to get your answer. Can I hear everybody say, oh, I left it for last. Yes, I did. I wanted to leave that for last because I really wanted you guys to understand the multiplication process. But yeah, this is a nice little feature that you can remember. Once you know what the result of your matrix is going to look like, is it a 3 by 3? Is it a 3 by 1? You simply place dots for the type of matrix you're going to get, and you write down the location of that dot. And the location of that dot tells me which row by which column. So for example, if we look at the second dot, right, that's 1 by 2. That tells us we have to multiply matrix, the first row in that first matrix, by the second column in my second matrix. And if you observe in this question, that is definitely 100% true. So you can use that method, guys, and you can use it as a safety net to remember how to multiply which row by which column. And this, I think, is key to a lot of students when I show them eventually when they discover it. Yeah, they definitely use this all the time. Right, guys? I would say the heart of the matter is always to remember that you always choose rows from your first matrix and columns from your second. Do not mix it up, and make sure you know what a row is. A row is horizontally written. A column is vertically written. Okay, guys? And the last thing I wanted to add to this video, because this is the last video we will be doing on this basic multiplication process, at least for 2 by 2 matrices. I'd like to just show you guys what an identity matrix looks like. Okay. Identity. What is my identity? What does an identity matrix look like? Well, an identity matrix has a property, actually. It is a matrix. It's a special matrix. An identity matrix, first of all, to begin with, is just a matrix that looks a particular way. It has all numbers that belong to its diagonal, starting from left, going all the way down to right. It has all numbers in its diagonal being value of 1, only the value of 1, and every single thing else zeros. So for example, if I were to have a 3 by 3 matrix, then you would have all of its diagonals being 0 and everything else, all of its diagonals being 1, everything else being 0. So this is what an identity matrix looks like. And exactly what does it do? Well, let's just say we had a random matrix A, and let's just say A was 1, 3, 0, 2. Doesn't matter, just a regular matrix. If I were to multiply that matrix A by the identity matrix must match your order. So if it's a 2 by 2, your identity matrix has to be 2 by 2, a 2 row by 2 column matrix. Identity matrices work in such a way where when you multiply a random matrix by it, the resultant matrix gives you back the original matrix. So there's no change. There's actually no change whatsoever to the matrix you're multiplying it by. So if I want to multiply an identity matrix by some very humongous matrix that has difficult numbers like negative values and fractions, there'll be no change. Multiplication by the identity matrix just gives you back the very same matrix. Let me give you one last example over here. You guys can test it if you want. If you have a matrix, let's just say 3, 2, 5, 4, and you want to multiply that by 1, 0, 0, 1, multiplying by the identity matrix here. If you were to perform your very huge calculation, you'd get 3 by 1 plus 2 by 0. Over here, you'd get 3 by 0 plus 2 by 1. Down here, you get 5 by 1 plus 4 by 0. And over here, you'd get 5 by 0 plus 4 by 1. In working those out, you will end up seeing that you still get 3, 2, 5, 4. You guys can work that out on your own. You'll get the same values, right? So pretty much an identity matrix is one where no matter how many times you multiply by that identity matrix, you always get back your original matrix. So that's just a cool little neat fact about identity matrices. And it does play a role in the future when you are doing further topics on matrices. So guys, I know it was a lot. I know it may have looked challenging, these multiplication processes. I will say it is. It's very easy to make small errors, as you guys would have seen me do. So the heart of the matter is that I want you, when you are doing these questions and you find yourself struggling and you feel like I'm just not good as everyone else, they just get their answers straight away. You know, I mean, just think of the reality. It's just a bunch of numbers you're working with. And so what? So what if you make a small mistake? The main thought is that you understand the method, you understand the application, and the error is just a little calculated error. I mean, it's a human error. It happens. It doesn't mean you don't know what you're doing. It just means that you need to take more time and just check over your work again. Okay, so I hope that this video was sufficient with enough examples for you guys to understand basics of matrix multiplication. And of course, if you guys want a full tutorial where we just sit down and do multiplication after multiplication, I am so down for it. Just make sure you like and comment that you would like to see more of these videos. And if I see a sufficient number of students asking for them, then I will do a full tutorial on multiplication. Okay, guys, so thank you so very much for watching my videos, and I look forward to seeing you guys again when we'll be moving forward with another chapter of matrices. Goodbye.